All right, boys. So 16.3 is a little bit more difficult, and now things about to get real here in 16.4. It gets pretty intense here because this is all applications of how to use these matrices. Obviously, there's some more simple applications because it's literally one lesson in a high school math book. However, it is a little bit more complicated, so you want to stick with me pretty closely as we go through this. So the first one, we've got two types of problems here. One of them has to deal with like tournament style stuff, how to decide the winner of like a sports tournament. And the other one here is communication networks within computers. So with these networks, right, communication network is just set up like this. A, B, C, and D here all represent computers, and these arrows indicate which direction data can flow. Okay, so if you see here, we've got these double arrows, but we've also got some single arrows here. So for example, A and B can send information to or from each other, but B can only send information to D. D has to send information to B through C, right, or C and A. So you can kind of see how that works. Now to go into the technical things is a little bit out of our league. All we need to know is this to solve these problems. So matrix X, you could take this communication network and you can translate it into a matrix. And so this matrix, I see I labeled here, the rows indicate from which computer, and the columns here tells you which direction you're going to. Okay, so if label these real quick, we've got computer A, B, C, and D, and A, B, C, and D. So all we have to do is map this and see and ask yourself, can data flow from the computer on in that certain row to the computer in that certain column? The answer is yes, you put a 1. If the answer is no, you put a 0. Okay, yes equals 1, no equals 0. All right, so can we send information from A to A? No, that doesn't make any sense. Right, it's got to go out. You got to send information out. Can you send information from A to B directly? Yes, that's a 1. What about A to C directly? Yes. And A to D directly? Not directly. It has to go through something else. So the answer there would be 0. All right, B to A is true. B to B doesn't make sense. B to C works. B to D works. All right, C to A, yes. C to B, yes. C to C, no sense. C to D, no. And lastly, D to A does not work. D to B does not work. D to C does work. And D to D doesn't make sense. All right, so there's our filled out matrix illustrating this network of the flow of data between the computers. Now, moving on from there, what can we do with this? So with that matrix X, all right, we can actually I mean, you could do this by counting, but if you just use this matrix, you could calculate the number of routes. The number of routes that one computer can send data to another through exactly one relay point. So, for example, A can go from A to B to C, right? So you can go do that with one route, right? But you could also go A to B to C, right? Or A to B to D, or A to B, then back to A, right? All of those would work. So you could count all those up, but it would end up taking forever. So instead, you could just use the matrix X squared. What that means is taking this matrix right here, matrix X, and multiplying it by itself. And we just learned how to multiply matrices, so we can do that very quickly. Now remember, in order to multiply matrix, you multiply each row by a column to get that certain element in the new matrix. So what that means is, in order to find the first element, all right, we've still got A, B, C, D, and A, B, C, D. So in order to find the first element on the first row, okay, first row and first column, you multiply first row times, remember we're multiplying by itself, so I could draw another one here, but, well, I guess I could do it really quickly. Okay, so we've got that there. Multiply that by Let's use blue so it's not confusing. First row by the first column. Do the dot product there. So you multiply all those together and add up the results. What are you going to get? 0 times 0, 0, 1, 2, 0. Okay, so we've got 2. Right? And you can continue, so on and so forth, all the way through. Now when you continue, let's use a different color just so you can see it. So we're also going to do first row by the second column. All right, when you do that, when we get 0, 0, 1, 0, it would be 1. So if we're in the first row, second column, it's 1. And you can finish out the rest of this matrix by continuing to do the multiplication. You guys could do that at home. So it's going to look just like this. 1, 2, 1, 1, 1, 0, 0. Right? And once you get done with that, you can come up here to the network and check it and make sure it makes sense. So how many paths can you take to go from A to A? Well, you can go from A to B and then back to A, or from A to C and back to A. Remember, we can only go through one other relay point. Well, how about from B to D? Is there any way to go from B to D through just one relay point? Well, you could go from B to C, but you can't get to D from there, so that doesn't make sense. You can go from B to D, then that doesn't make sense. What about B to A? Nope, that doesn't make sense either. All right, so there's no way to do it. That's why it's a 0. That's how it works. So there's also two other ones that you could use. The matrix x plus x squared is the number of routes that, that a computer can send data through no more than 2 relay points. And then x plus x squared plus x cubed is 3 relay points, and there's more, so on and so forth. But that's obviously really complicated. So the other type of application here is just a dominance relation. All right, a dominance relation is it's basically a way to grade teams in a tournament. Okay, so this is a volleyball tournament that's used in the in this book, and the way that they set it up is the Broncos beat the Mavericks, and the Knights but lose to the Raiders. The Mavericks beat the Knights, the Raiders beat the Broncos and the Mavericks, the Knights beat the Raiders. So you fill out the wins and losses in this table, and you get your matrix. So we'll fill out our teams. We've got the Broncos, the Knights, the Mavericks, and the Raiders. Broncos, Knights, Mavericks, Raiders. So that gives us our rows and our columns. So you fill out the wins here on wins and losses in this way. So obviously, you know that the Broncos didn't lose to the Broncos, but they did beat the Mavericks and the Knights. So they get a 1 for both the Mavericks and Knights, and they lost to the Raiders, so they get a 0 for that. All right. For the Knights beat only the Raiders, so they get a 1 there. Everything else is a 0. Right? The Mavericks beat only the Knights, so they get a 1 there. Everything else is 0. And the Raiders beat the Broncos and the Mavericks. Losses everywhere else. Okay? So that makes perfect sense. That's our matrix. Just to illustrate the dominance relation is what they call it. Now, to continue on from that, you can get a second stage dominance. Okay, so that means that whole, we beat them and they beat them, so we must have beaten them type of thing. That whole thing. Like, oh, the Broncos beat the Knights and the Knights beat the Raiders, so that means the Broncos beat the Raiders. That whole stuff. Okay, so that second stage dominance is going to be helpful here. So when we fill out the second stage dominance, it's just m squared, very similar to same process as the other, the computer one. So we have to multiply this matrix up here by itself. All right, and you guys can do that because you know how to do that now. When you're going to answer should look like this: 0, 1, 0, 1, 1, 0, 1, 0, 0, 0, 0, 1, 0, 2, 1, 0. Okay, so when you get that, the whole point of this thing is helping you try to decide the winner. Okay, so you look at first stage dominance here, M, and second stage dominance. When you combine them, you'll break a tie. If you look at just the regular dominance matrix up here, right, there's a tie between the Broncos and the Raiders, but that tie will split when you add in second stage dominance. All right, so when you add those two matrices together, your answer is going to look like so. 0, 2, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 2, 2, 0. All right, so now when you add up all the wins in the rows, you see we've got 4, Broncos get 4, we've got 3, 2, and 5. That makes it very clear that the winner of this tournament should be the Raiders down here at the bottom. All right, that's the whole point of second stage dominance. So we'll finish up here with just one more example of each of these types of problems, and I'm going to go through these kind of quickly, so you'll probably want to pause this and slow down, but it's just helping you guide you through a couple examples before you come in and try to get to work in the class. Okay, so we have to write the communication matrix for this network up top. All right, so we know we're going to have a 4 by 4 matrix, and we know that we're looking for from up here and to up there. All right, we've got A, B, C, and D from top to bottom and left and right. Okay, so we know that we have zeros all the way across because that doesn't make any sense. All right, can A go to B? Yes. Can A go to C? No. Can A go to D? No. What about B to A? No. B to C? Yes. B to D? Yes. C to A? Yes. C to B? Yes. C to D? Yes. And D can go to B and C, but not A. So that's our communication matrix. All right, now from this we can answer this quick question. Which ship can send messages to the greatest number of other ships? We've got, right, A, B, C, and D. You just count straight across, right? Because that's how many they can send. If you look at this row, it tells you how many A can send. Well, they can only send 1. And you could also look at the diagram and count, but you can see there that A is not going to make sense. B sends 2, C sends 3, D sends 2. So the obvious one is C, because it sends it can send messages to 3 other ships. All right, now we want to write the matrix that can be sent by using exactly one relay. All right, so that's going to be our x squared, or whatever our matrix is called squared. We didn't name it, so it's called x. All right, so x squared, got to multiply by itself. When you do that, you guys can do the calculation. I'll just show you what you should get there. You should get 0, 0, 1, 1, 1, 2, 1, 1, 0, 2, 2, 1, and 1, 1, 1, 2. That should be your x squared if this is x. All right, so check your calculation, make sure you got that right. And finally, this last question is just answering how many ways can a message be sent from ship C to ship B by using no more than one relay? The key there being no more than one relay. No more. Okay? No more means if we're looking from C to B, right, this is using one relay, and this matrix up top from C to B, so that number, right, is using 0 relays. So that means we need to add those two numbers up, right, from C to B, using no more than one relay, so either 0 or 1 relays. So that means we add up 1 plus 2, and the answer is going to be 3. Wonderful.